Okay, now let us explain about how the lowering of the activation energy capable to done by the enzyme. Okay, before this, before we enter the discussion, there is actually a condition that you have to understand. When the reactant receive enough energy, receive enough activation energy, they will enter a condition known as transition stage, where the molecule of the reactant become less stable and the reactions start to take place, meaning that the formation and the breakdown of the bond will start to actually take place during the transition stage. Okay, so that is the explanation about the transition stage. Okay, before this, let us just go through about how the presence of enzyme eventually able to lower the activation energy. Before we discuss in detail on why, just look at your bullet. You're going to notice that the first step, how enzyme capable to reduce activation energy, the substrate must bind with the active site of enzyme. That is very essential. If the substrate is not inside the active site of the enzyme, then they will be not going to have any function for the enzyme to the chemical reaction. Okay, so after the enzyme substrate complex is formed, meaning that after the substrate has eventually bind to the active site of the enzyme, the whole molecule is called the enzyme substrate complex. Then only the enzyme or the active site capable to reduce the activation energy. So how they reduce the activation energy? So there will be the explanation involved. The active site will stretch the substrate molecule towards the transition stage. They were going to facilitating the formation and the breakdown of the existing bond in order to actually make the products more easier to form. So you can actually see the diagram like this. Okay, but how? Okay, how? So in order to explain how, then there will be then you have to actually explain the function or the role of the active site, which is the template for the substrate. Okay, the template of the substrate. So what does the active site do? So the active site first will bring the substrate. Okay, they will bring the substrate in the correct orientation. Okay, the substrate will be held in correct orientation. So what does it mean? How does this help in the reaction? So in two different situations, if I give you two situations, you look at the substrate. So when I have the substrate A and B, I need to form a covalent bond, and covalent bond is formed between the hydrogen and the hydroxyl group normally. So if I have the orientations arranged at the first situation like this, and I have the second substrate, which is actually holding the orientation of the hydroxyl group and the hydrogens like this. Okay, so first and second condition, which condition will be easier for the reaction to start? Definitely is the first condition, because the functional group is actually arranged side to side, which is near to each other. So it is very simple for the active side to actually initiate or starting the reaction. Okay, compared to this situation, if you look at the second condition, the functional group is very far away from each other, so the transition stage might not be so successfully entered. Okay, next, what else does the active site do? Active site also we're going to stretch, meaning that apply some of the strength to the substrate so that they were able to actually speed up the reaction. So the nearer the substrate itself will be faster the changes or the breakdown and also the formation of the new bond will actually presence in a higher rate lah. So if you see if the length between the substrate A and B is in this particular length, definitely it will be slower compared to the length at these two molecules. So this one is actually being applied with the strength. So they have the stress that apply by the active site. Okay, so then the active site also provide the favorable microenvironment. This one is explaining to the correct pH, correct temperatures, the correct orientation. So that is the favorable microenvironment. And also the active site participating directly in the catalytic reaction. This one might be a bit confusing because active site, how can they actively participate directly inside the catalytic reaction? Okay, so this one is actually referred to the transferring of electron. In some of the reaction, not the covalent or the formation of covalent bond or the breakdown of covalent bond, in some of the reaction, we actually need the electron to be transferred from one molecule to another molecule when the process is run on. Okay, but this one might actually require a very large consuming of the energy. So therefore, active site is actually act as the intermediate that which able to receive the electron first, and then only provide the electrons back to the molecule B, which is forming an intermediate between them, and this particular process will actually require less energy. And this is explained through the direct participating of the enzyme or the active site in the catalytic reaction. Chapter 5 later on during electron transport change, we're going to see this particular example. Okay, so that is the basic explanation on how the lowering activation energy can happen when the enzyme is when the substrate is actually bind to the enzyme at the active site. So that's it for this video.